Lesson 1, Fundamental Counting Principle. So when you're doing these questions, make sure you read through the question, and it's usually helpful to make some kind of visual or chart or diagram or table, and that's how it's easiest to help get to your situation to answer your problems. So the members of a recently selected varsity basketball team meet each other at their first team meeting. Each person shook the hand of every other person. The team had 12 players and 2 coaches. How many handshakes were exchanged? So you can do this and get 14 people and have everyone shake each other's hands, and that's wonderful. Or you can draw a diagram, and that's really easy as well. So we have 14 people, and it's really easy to do this in a circle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if you start with your first person, they're going to shake hands here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. The next person starts, they don't have to shake hands with that person they already shook hands with. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they make 12 handshakes. So that's 13 handshakes plus another 12. Now we go to the next person. So they don't have to shake hands with the first 2 people. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So as you can see, there's starting to be a pattern. So as you keep continuing making handshakes, it is going to be 1 less than the time before. But if you keep continuing, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to the last person to shake hands, 7, 8, 1, 2, 3, 4, 5, 6, 7, you will notice something at the end. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. 1, 2, 3, 4. You would think that you would just keep adding them on. 1, 2, 3, which does make sense. 1, 2. And the last person actually doesn't shake anyone's hands because they've already shaken hands with everyone else before them. So you take all of this, so what it looks like is it's 13 plus 12 plus 11 plus 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, which is 91 handshakes. Example 2. Using a standard deck of cards, determine the possible ways to draw the following: a single black card or an ace. So there's 52 decks in a card, which means there are 26 black cards, and there are 4 aces, 1 of each suit. So if you're going to pick a card that is black or an ace, we want to find N of B or an ace. So we would use the principle of inclusion and exclusion. So N of B plus N of A minus N of B and A. So remember, we can't count the black aces as well. So we'd take 26 plus 4 and minus 2 for the black aces. So there's 28 ways you could draw either a black card or an ace. If you wanted to draw a single red card or a 10, there are 26 red cards and 4 10s. So it's red or 10. So again, you have to subtract the red 10s. So number of reds plus the number of 10s minus the number of red 10s. So 26 plus 4 minus 2 is 28. So there's the exact same amount of ways that you could pull a red or a 10 as pulling a black or an ace. Determine the number of ways of drawing a single card, getting a 2, then drawing a second card and getting a face card. So we've got 4 options first. You're going to either have a 2 of hearts, a 2 of clubs, a 2 of spades, or a 2 of diamonds. I mean, I could have just put the initials there, but I definitely wanted to draw them out. And after that, you want to get a face card. So there's 1, 2, 3 different kinds of face cards. Jack, Queen, and a King. And there's 4 different suits. So diamond, club, spade, heart. I am not writing that all out. So what that means is that there's 12 different ones right here. There's 12 ways to do this, 4 of each kind of face card, and there's 4 times we can do that. So it's the same as if you pick a 2 of spades first. There's 12 different face cards. There's 12 different face cards if you pick a club first, and there's 12 different face cards if you pick a diamond first. So really, if you add this all together, there's 12 plus 12 plus 12 plus 12, which is 48 different ways. Another way of saying that is you could take how many options for the first one, which is 4, and multiply how many options for the second event, which is 12. So I like to do it with two lines. So this is the different kinds of 2s, and this is the different kinds of face cards. So we know that the number of 2s is 4, and the number of face cards in a deck is 12. So you take 4 and you multiply it by 12 to get 48. If you want to draw it out like a drawing like this, you can. You can even draw out each individual strand, but that won't be very time sensitive. But this is a little bit faster. Example 3, Hannah plays on her school soccer team. The uniform has 3 different sweaters, red, white, and black, and 3 different shorts, red, white, and black. So, if we did shirts first, then shorts, the N of shirts is 3, and the N of shorts is also 3. If we wanted to do this out visually, we'd have 3 options to start for shirts: red, white, and black. From there, we'd have 3 options as well: red, white, black. Red, white, black. Red, white, black. So this means that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different options. We can also take our 2 events, which would be the N of shirts, and multiply it the N of shorts. So 3 times 3 is also 9. So you can always use the fundamental counting principle, which is if you multiply your events together and the options for each of those events, you will have the number of outcomes. So that for that last example, we took 3 times 3 to get 9. So luggage opens with a correct 3-digit code. So we have a 3-digit code. That means we have 3 events. Each wheel rotates through the digits 0 to 9. So the N of the codes, so the number of different numbers in the code, let's put numbers, is 0 to 9. So that means there's 10 different numbers possible. 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And because it doesn't tell us that the numbers can repeat or not repeat, we can assume that they can, because why would it matter? So that means that for event 1, there's 10 numbers available. So that's like putting that into your lock. This is my lock from 0 to 9. So the first one, you can put any number in. The second one, you can put any number in as well. So it's also 10. The third one, you can put any number in. So there's 10 again. Multiply the 3 together, and there's 1,000 options. Part B says, suppose each digit can only be used once. So we still have a lock. It needs 3 digits. So if we put our first one in, we have 10 numbers possible. But say that number was a 1, or any number on there. That means for our second number, there's only 9 options left. Say our second number was a 8, or any number. Now there's only 8 numbers left. So we have 10 times 9 times 8, which is 720 different combos.